let's talk a little bit about how to translate geometric figures by using a coordinate matrix for the xy coordinates. Since we're doing the same thing to everything to all of the coordinates, using a matrix makes it simple to transform one to the other. And this is how computer graphics and programming is used. All right, so let's start with this matrix 1, 0, 3, 4, negative 4, 1, 1, negative 4. And it changes this coefficient matrix where these values represent x's and these represent y's. So we have the point 1, negative 4, which I've sketched here, 1, negative 4. I'm going to go ahead and delete out this other graph for now just so we can kind of see at first what's happening. Okay, we'll ignore the blue dots. So we have 1, negative 4. So right 1, down 4. And then we have 0, 1. So left or right 0, up 1. And then we have right 3, up 1. And then we have right 4, down 4. So you can see those 4 red dots make this parallelogram shape. Well, those 4 dots are moving to these 4 dots. So 2, negative 4. So positive 2, down 4. Over 1, up 1. Over 4, up 1. And over 5, down 4. I don't have the blue dot listed there. Anyway, if we connect those, we get that graph. And obviously, these aren't drawn perfectly because it's supposed to be the exact same shape and then moved to the right one. Now, how do I tell that it's being moved to the right one? Well, let's look at the x values. The x values have all gone up 1 in value. The y values have all stayed exactly the same. So it's not moving up or down at all. It's only moving to the right one, which means a matrix has been added to this matrix to get this one. And the matrix that's been added, I think I've got it right here, is, nope, wrong page. Nope, wrong page. Nope. Aha, there it is. So to move this right one, 1 has been added to all of the numbers on the top, but 0 has been added to all of the numbers on the bottom. And that is just simply taking this coordinate matrix and moving it to this coordinate matrix. So similar for question number 2, notice how to get from 3 to negative 4, we need to subtract 7. To get from 5 to negative 2, we need to subtract 7. And to get from 5 to negative 2, we subtract 7. But to get from 0 to 0, we do nothing. 5 to 5 is nothing. 0 to 0 is nothing. So we're basically taking this coordinate matrix, adding this transformation matrix to get this coordinate matrix for our transformed geometric figure. And that means that our whole thing has moved to the left 7 because our x values are all being added by a negative 7, which results in moving them left 7. If there's something happening to the bottom row, positive numbers would move it up and negative numbers would move it down. Okay, let's look at the other type of problem in this assignment. So we're trying to find the coordinates of the vertices after each transformation. So we have a translation that's going to happen 8 left and 5 up. They already gave us this picture. We're going to take all of those points and move every single point, G, H, and I, to the left 8 and 5 up. That would put our new triangle over here. And you can see that I counted out and found those coordinates. Now, how do we do this whole thing with matrices? Well, we would start by finding the coordinates for H, G, and I. And usually when they're labeled with letters like this, I go alphabetically. So G, H, I. So point G is at 3, negative 3. Point H is at 3, negative 2. And point I is at 5, negative 3. Well then, since we're moving them 8 to the left, that would affect the top row because that's where our x values are. If it was 8 to the right, we would do a positive 8, 8, 8. But since it's 8 to the left, we do negative 8, negative 8, negative 8. Then the bottom row affects up and down. Since it's moving 5 up, we've got a 5, and a 5 being added to the bottom row to move it 5 up. If we wanted to move it down, those would be negative numbers, but they would all be the same negative number to move the entire figure down that amount. So then we simply do the matrix addition and we get these coordinates. 3 plus negative 8 is negative 5. 5 minus 8 is negative 3. Negative 3 plus 5 is 2. Negative 2 plus 5 is 3. We get these coordinates, which match up with these exact coordinates. Same exact triangle, moved left 8 and up 5.